Okay, let me do one that has, this, I think this is what you were talking about. Destiny, were you talking about one that looked like this? When you said it had an odd shape?
Yeah, I think so. And it was like
Looked like a house?
almost like that. It was more like
What?
it was more like
You draw a picture, let me see.
more like this, and then it was like something like that.
Okay, and what did they want, the area?
It's actually in my phone because I had took a picture of it. Let me see real quick.
Oh, you were in the test? Or was this a learning?
No,
Oh!
it was a Praxis. It was a Praxis practicing thing.
Okay, you're fine. I was like,
But it actually ended up being on my test, and I actually got it right. So I think I got it right.
okay, good. Well, perfect. Yeah, let me go ahead and say that. That'd be an excellent property,
It was okay. It's not in my pictures, but it's on the Praxis test.
Okay, the practice. All right, so let's say you get something like this. We'll just draw it like this because it doesn't really matter. The way you work it is the same.
I think that's what it looked like.
Okay, what you're doing here is you're going to cut this into pieces that you know how to work with. All right. Yeah, you have a triangle here, right? And then you have a rectangle here, and you have another rectangle here, and you have another rectangle. All right? Does that make sense?
Yeah.
So you need to find the dimensions of each of them. I'm assuming they did stuff like this. They probably told you this was 2, this was 3. Let's go ahead and do this. I'm going to make this connect because otherwise they usually give you enough information to where. So we'll go ahead and do this, all right? And you'll see. Okay, so that's, okay, so this is, yeah. All right, this is 2, and they'll tell you, let's see, what else do they tell you? They'll tell you that's 2. They might give you, this from here to here is 6, like from here to here, right? And, or they might give you the total distance. I don't know. They give you different things. They'll tell you this side is, let's do 5, and then they'll tell you this piece right here is also 2, or something like that, right? So then you have to fill in all the things. Is that what, did they give you measurements for different ones? Okay. So then, and then they have to give you something. They might tell you this is, you know what, they would tell you this was a isosceles right triangle. Yeah, that's exactly what they're going to do. Okay, so right away, what do you know if that's an isosceles right triangle? Isosceles means side length of the same. Right triangle means it's a right triangle. So you have 2 things going on here.
So you know that other one's going to be 6.
This has to be 6 as well, because isosceles means the legs have to be the 6, and that.
Use your Pythagorean theorem.
Well, now be careful because you're not looking for the side length. You're looking for area. Was that what you were being asked to find?
I think so.
Yeah, which is, I understand exactly where you went, but this is what I wanted to bring up too. Is be careful. If you're doing the Pythagorean theorem, it gives you the length of this, but what do you need for the area of the triangle? You need to have base and height. Now, right triangles are special in that the base and the height are the legs. So if you have a right triangle, you don't have to find the hypotenuse. The hypotenuse is irrelevant. Okay? The right triangles are their own base and their own height. So you already know that you have 1/2 6 times 6. So that was much more convenient than you would have originally thought. What is? I'm sorry. Go ahead.
I was just going to try to figure out.
Yeah. Go ahead and do it real quick.
So you know, the top of that rectangle is going to be 3. Because
Okay.
You start over there at 6.
Mm-hmm.
And it adds up to 9 total. Well, am I doing that right?
You're talking about the
like
top
the bottom
of this right here?
Rectangle down here, yeah, it's 3.
This is 3?
Or like up here on the top right, it would be 3 too. Wouldn't
Yes,
it?
you're right.
Yeah.
That's right.
Okay, and then down there would be, so like that 3 and 2 makes it 5. So then that would
Oh,
have to
you're
be-
saying this piece right here?
Well, like yeah, before it was at 3 where you put it, and then now down here at the bottom of this rectangle would be 4, wouldn't it?
Yes, that is right.
And then the other side would be 5. Or
Yes.
Right, yeah.
Yeah, this is 5, and there's one more measurement that's going to
And
be.
then that other side.
What is this right here?
Oh, that's 5 too. Right?
Just this red part right here,
Oh,
because you
red-
gotta find the
red
area of this
part.
little guy.
Wouldn't it be, 3?
Yeah, good, very good, excellent, yeah.
Okay.
Because this whole side is 5 and you got 2 of this left over. So you gotta do some cut and pasting. If you're told information, always draw a picture, always draw a picture, because a picture's worth 1,000 words. It makes it so much clearer to you on what to do. Okay, so now it's just a matter of getting the areas and adding them together. So the area of this is gonna be what?
It's gonna be 20.
Good, 20, right?
Feet squared.
Yep, yep, and then this is gonna be, what's this gonna be?
6.
Yeah, 6, right? Okay, you got that, because you got a 3 times 2. And this is gonna be 15. And then your triangle is gonna be, and by the way, remember multiplication is commutative, so you can multiply in any order. I would multiply half of 6, which gives you 3, then 3 times 6 is 18. Or you can do 6 times 6, which is 36, and multiply it by half. No matter how you do it, you get 18. So do whatever makes the best sense to you. So you end up, when you add all that together, what do you end up with?
20, 15 is 35, 41, and 59.
Good. And again, what you said a minute ago, 59, some kind of units, it might be meters, let's do meters, usually they give that stuff in meters. Meters squared, don't forget, if this is the fill in the blank, don't forget your squares. Because if you just put 59, the answer's wrong, totally wrong, because it's not, and they are big on units, they will consider that wrong. Because even though you found it, or if you get, like, if it's extra points, you only get half at the very most. And then all you got to put was your units on, so be sure to put your units on. So what we've done is multiple examples of how to find area using shapes and connecting the information we have with the shapes and doing the triangles. So that's a big, I think that's probably, if you go and do some more, that's pretty good use of triangles. Look at number 17 on the, let's see, let's go back to this. Number 17 is some sort of a triangle problem. I just looked at it, although I'm not sure exactly what it asked. There it is. It says, if the equilateral triangle above is rotated clockwise and its center is point B. Okay, this is rotation. It's symmetry, where you rotate objects, you reflect them, and you slide or translate them. Do you guys remember that from geometry?
Yeah.
Okay, well, a slide...
The only thing I know is when you reflect it, I know you can draw it like the opposite way.
Yes, yeah, when you have the line over here, what would the reflection look like? Well, it's going to be, every point is the same distance from the line of reflection, is what that boils down to. So over here you have to be, A has to be that far away, and this B has to be this, I call it B prime. And then when you connect the dots again, you should have an exact mirror image across the line of reflection. That's a reflection, exactly. So every point is perpendicular to the line, and it's exactly the same distance. Think of it as like XY axis. It has to be all the way over. This is asking about rotation. Does it tell you, this is an equilateral triangle, which is huge, because equilaterals, they look exactly the same as you rotate it, because all sides are the same. Could you rotate an isosceles anywhere before you went all the way around and make it look the same? No, because anywhere you go, you're going to have different side lengths until you go all the way back up. Equilateral triangles. So how many times could you rotate this? Let's let this be blue. This will be red, and this will be green. All right. How many ways, if you rotated it once, you would have what? I mean, how far could you rotate it to get the exact same image? This becomes red. This becomes green. Blue. Wait, I did that wrong. This becomes, I said green, but I drew red. This becomes green, and this becomes blue. All right. So I've just rotated it. I've just rotated it one time around. Right? You guys see what I'm doing?
Yeah.
So the
So
green.
that's supposed to be green, right?
Yeah, I keep saying green, and I keep drawing the wrong color. Sorry. Green is this color. All right. There you go. Sorry. Yeah. Green. Right.
Mm-hmm.
Then could you rotate it again to where green went to here, blue went to here, and red went to there?
Yes.
Yeah, so that's 2 rotations, and then finally the last rotation will put you back. So how many times could you rotate that to get the same image? 3. Okay, what's a full rotation? 360. So divide 360 by 3, what do you get? Take the 0 off, divide 36 by 3. How many times is 36 divided by 3? Yeah. 36 divided by 3 is 12. 360 divided by 3 is 120. Okay, so the question says, which, I'm just pointing out where this came from. If the equilateral triangle is rotated clockwise about its center, so the point B in the new image corresponds to point A, so point B corresponds to point A, which of the following would be the number of degrees of rotation? And we're rotating it clockwise, which is this way. So B is going to go all the way around to here. So how many rotations did you do to get B all the way to A? You rotated it twice. Each rotation is,
120.
so two 120s is 240 stands for D. Okay, yeah. And the only things you can rotate like this are rectangles, squares, and triangles. Because everything else is too oddbally to work. So a rectangle only has 180 degrees of rotation, right? Because it only looks the same as itself when you're upside down. A square has how many angles of degrees of rotation? How many times can you rotate a square and get the exact same picture?
4.
4 times, yeah. So each rotation is how much? 360 is the whole thing. If you divide that into 4 rotations, you have what per rotation?
36 divided by 4.
36 divided by 4 is 9. So 90.
Yeah.
So each rotation is a 90-degree angle, which just happens to correspond with the angle measures, right?
So it just anytime you rotate something, it's 360 basically.
And the whole rotation is 360. If it rotates once and looks exactly like it started, then that would be 180. That's half of 360. If it rotates 3 times, you divide 360 by 3. That each rotation is that number of angles.
Oh wow.
Yeah, exactly. So and there's not like that many things that rotate.
Yeah.
And then when you do that, pay attention to whether you're going clockwise or counterclockwise. Because if A had said counterclockwise, it would be that way, and B to A in this case would have been 120 because it's only one rotation.
Yeah.
So you need to pay attention to which way you're going.
Now you gotta remember it's how the clock goes.
Yeah, exactly. Yeah, which is where that comes from precisely. Okay, does that make sense?
Yeah.
And that's rotation pretty much. Rotations are transformation, and that's what you're going to get. They might have a graph on here where they do rotation. I'm not sure. I'll look.
That's what they usually do. Have a graph.
They have a graph.
Yeah, they'll give you A, B, C, and D, and you have to find what the answer would be if it was reflected or rotated or.
Got it. I know what you're saying. So this is the picture, and they tell you the points, or they just say A, B, C, and D.
They actually have a point.
Okay, so let's go ahead and do it. So we'll call this, let's see, 3, 6, and we'll call this 6, 1, and we'll let this point be 2, 2, 2. Okay, and then they ask you what would it look like if it was reflected across the x-axis?
Yes.
Okay, so that's the question. So this is a reflection. This is where what I said before, you have to go perfectly perpendicular to your line of reflection, which is the x-axis. And the distance you are from the axis on one side has to be the same as this. So if you look, are the x's shifting at all? No, the whole thing's just going down, right? So this point goes down to here. I'm going to go ahead and draw this in a different color, right? This point goes down to here. So it's going to go a little bit further. This point goes all the way down to here, right? So your x's aren't moving at all. So your new points all have exactly the same x values as the original ones did. The only thing that changed was what? The y's. Yeah, and they only became negative. This becomes a -2 because it has to be, if this is 2 away from the x, down here has to be 2 away. And this is going to be a -1, and this is going to be a -6, and that would be the answer. Okay, so you were fine with those?
Yeah, that was.
Oh, okay. All right. Well, good. Then that's good. But that's an example of reflection, which is what they. Yeah. Okay, got it. So that's what they do a lot. Okay, so let's see. This is actually good because if I put this video up, someone who's watching it will actually probably question like that. There was a probability question I wanted to do here real quick. That was right above the triangle question. Okay. There are 36 students in the photography club at the local high school. I'm looking at number 16. If there are half as many boys as girls in the club, how many girls are in the club? A lot of people will say the answer is 18, which is half of 36. That's not the right answer. If you read it carefully, it's saying half as many boys as girls. Well, you can't have more than you know, you have to have less than the whole to start with. So this is interesting, that you are looking for basically, if you have the, let's see, the half as many boys. So the boys are equal to 1/2 of the girls, right? So you're looking, what you've got here, if you draw a picture, this is much easier to explain. If this is the number of boys, then this would, if this is the number of boys right here, then this would be the number of girls would be here. Because this is half as much as this. Does that make sense? This is your whole. You need to draw a picture where whatever this size is, this blue, the green is the boys, whatever the green is, you can make half of that, which is about this much.
Oh, with the girl.
Yeah, but how much is that, really? I mean, look at the picture. What are the girls out of the whole? Yeah, they're a third. So even though it looks like half, you're actually looking for a third.
So D 12.
Yeah. Yeah. Sometimes, you know, the best thing to do is draw a picture and just make it work. And so, you know, we know half as many boys as girls. If this is the whole, the boys are this much, the girls are half of that. Well, that means these two pieces have to be the same, right? So if this side piece is the same as this piece and the same as that piece, what you have, because you've got equal portions or fractions, you've got 3 fractions the same size, you've got thirds.
Yeah.
So one of those would be the girls and 2 of the thirds would be the boys. Does that make sense? Yeah, so that one, I thought that was a probability. I thought I saw a probability question in there. I was going to do a probability question. Oh, let's see if I can find one. Oh, this is not a pointer. Yeah, let me go ahead and. Statue of Liberty. This is a geometry one, the Statue of Liberty, I think. Oh, yeah, this is a proportion problem. You guys know how to work these? This is good old proportion, the shadow thing.
Oh, so yeah.
Yeah, you're good.
Uh-huh.
Yeah,
You
this
would
is.
have like one over the other, then another one over X.
Yeah, this is. These are always going to end up looking like this. All right, where the bigger one is this vertical distance, and then the smaller one is this vertical distance, and then the distance from the object. Now, the only thing you have to be careful is this red goes all the way to here, whereas the blue is just part of that. These have to be proportional. They have to set up as proportional fractions. So the Statue of Liberty casts a 37-meter shadow, 37 meters long. So this whole red is going to be 37. At the same time, a nearby vertical 5-meter pole, so this is going to be 5. Cast a shadow that is 2 meters long, so this is 2. And it says the height of the Statue of Liberty, which is your unknown. So we'll got that S for the Statue of Liberty, right? Okay, so now what does this look like as a proportion? That's supposed to be an
Would
S.
it
It
be
looks like a 5.
37 over X equals 5 over 2?
Yeah, there's actually more than one way you could write it. 37 over S equals, now you have to be careful, it wouldn't be equal to 5 over 2, why not?
2 over 5.
Yeah, you have to keep like to like.
Yeah.
37 is the base, so what you've just done here by doing 37 over 2 is you've done base to height, right?
Yeah.
So any proportion has to also be base to height.
Right.
So that would be 2 to 5. You could also do it another way. I mean, there's not just one way to do it. You could also have done height to height, S over 5, where S is the big. This is, now in this case, you're doing height to height, so this is big, little. You see what I'm saying?
Mm-hmm.
So that could also have been height to height. And that's S is to 5, and then you're going to do big height, length, which is 37, is to little length, which is 2. Either way works, and either way is going to give you the same answer. And then you guys know what to do. You cross multiply, right?
Yeah, if I multiply it and divide, right?
Yes, you end up with 2S equals 5 times 37, whatever that is. And then you're going to go ahead and divide 2 on both sides. And 5 times 37, I don't know what that is right off the top of my head, but you're going to end up with 5. What is it?
185.
Over 2, which is 185 over 2. Okay? And that will be your final answer. And you would get the same thing here. You're still gonna get the same thing. This is gonna give you 2s, so not an 8, that's an s. 2s equals 37 times 5. Okay?
So what would the answer be right there? They don't give me like that answer. They give me a different
It's
answer.
like within the range, so that's 92.5.
Oh,
So
okay.
that, yeah, it's in between.
190. Okay, that, yeah.
Yeah, 185 is, half of 185 is about 90, half of 180 is 90, so it's gonna be between 90 through, it's gonna,
92.5,
Yeah. yeah, so it's somewhere, the reason they're doing that is they're keeping these and plugging the number in. They're trying to stop you from reverse engineering the question. And that's, that's what they're looking for. A total of 12,000 was divided among the first, second, and third place winners in the ratio of 3 to 2 to 1 respectively. How much did the first place winner receive? So what this means is they won 3 times as much, 2 times as much as the first place, right? So this person got this much, this person got twice as much, this person got 3 times as much. So what I would do, I'm not sure if this will work, we'll try it though, is I would say, we don't know how much the first person got, right? So the first person got X. The second person got 2 times that amount, right? And then the third person got 3 times that amount. And you know when you added them all together, see what I'm doing? That gave you your total amount, which was 12,000. Now that's the way my mind works. I don't know if that works for you guys either. But when, I think of ratios, I think of twice as much, 3 times as much. Well, this is just a simple algebraic statement. X plus 2x plus 3x is going to be 6x equals 12,000. And then if you divide both sides by 6, you get 2,000, right? Now, this is where you have to stop and ask yourself, what did the question want? Because if you put down 2,000, it's probably going to be wrong.
How much did the first place winner receive?
Yeah, the first place person got 3 times as much. So your answer is actually going to be C. Yeah, so always be careful when you do this to make sure you go back and read the question, because you want to answer, you have the right work, but you're going to get the, so,
They
yeah.
don't go about work. They don't even look at your.
No, they don't. No, they don't. Now, the other thing that would help you here is 2 is not an option, so you
Right.
could have said either you did something wrong or you read the question and then it's like, oh, they want the third place, so that would be 6. And then you make sure the ratio works. If the first place got 6,000, and that means the second place got 3,000, and the first place, wait, did that work? Wait, 3 times, oh yeah, 6, and then second place got, 4,000, and then the last place got 2. Yeah, that does add up to 12. Yeah, there's a way to go backwards, I guess.